On my screen is the simple network topology, whereas in I have a PC 10.10.10.1 behind the FortiGate Firewall LAN interface, port 3, configured with an IP of 10.10.10.108. And on the other side, we have port 1 and port 2. Both are connected to ISP1 and ISP2. Port 1 is statically configured. Port 2 is dynamic, which means it gets the IP address from the ISP device. So port 2 is dynamic in nature. And in this tutorial, I'm going to show you how you can configure SD-WAN when the WAN interface is dynamically configured, or when the WAN interface is receiving the IP from the remote device. Basically, a DHCP is configured on WAN port. And nothing much when it comes to the topology. It's pretty simple. Let's move on to our FortiGate firewall to check out the configuration. So this is my FortiGate firewall. As you can see, the interfaces WAN 1, which is connected to ISP1, is having static configuration 192.168.0.108. And WAN 2 is configured. It is configured to receive the address from the remote device. And you can see here it is receiving 14.140.40.108/24 from the remote device. And it is dynamic in nature. And the last interface is our LAN interface, which connects the client, which in our case is the Windows machine 10.10.10.1 connected to 10.10.10.108, which is FortiGate Firewall's LAN interface. So now let's start the SD-WAN configuration inside the network. Go to SD-WAN and create the SD-WAN zone. Let us try to create the SD-WAN zone. Let's name it as SD-WAN zone. And then let's try to create the SD-WAN member. So first of all, we'll select the port 1 and we'll set it to SD-WAN zone. Gateway, in our case, we know the gateway of WAN 1. So I'm going to update the gateway. So 254 is the gateway of WAN 1. I'm not changing any value here. Enable. So now we have one member here in the SD-WAN zone. Now let's try to create the other member, which is dynamically configured. So here we'll choose port 2 and we'll set it to SD-WAN zone. But here in this scenario, we don't know the gateway because it is dynamically configured. It is configured to receive the IP from the remote device. So you can select the dynamic option here inside the gateway. Gateway gives you the option of dynamic. If you have the information about your DHCP server, then you can specify. Otherwise, you can, select the dynamic option and then click OK. So now we have two members inside our SD-WAN zone, WAN 1 and WAN 2. WAN 2 is dynamic, WAN 1 is static. Now let's try to check out our configuration. So let's try to create the performance SLA first, whereas in which will decide the two links that we have here in SD-WAN zone. So let's try to create let's try to name it as SLA test. And let's try to use ping, and let's try to ping 8.8.8.8 to build up our SLAs. which will be, if you enable this latency threshold, we can keep it to, let's say, 11. Zero threshold, you can keep it to 5. Packet loss, you can keep it to 10. And then coming down to the next section, which is link status. These are the intervals, check intervals. So after 500 milliseconds, you will have the probes from the WAN links, port 1 and port 2, to check the liveliness for this particular IP, 8.8.8.8, to build up our SLA parameters. So check interval is 500 millisecond default. Failure before inactive is 5. So number of timeouts before interface shows as inactive. So 5 timeouts, and restore link after 5 checks. So if the probe is successful for 5 checks, you can restore the SD-WAN link, which is WAN 1 and WAN 2 in our case. Update the route, yeah. We have enabled this option, so it'll automatically update the route. I'll show you the route configuration as well. Click OK. So now we have our SLA. If you click on the SLA, you can see the graph that will build up. And you can see the latency for both the WAN ports, WAN 1 and WAN 2. If you go to SD-WAN zone, if you expand this, you can see both the interfaces are active. And these are the SLA. You can see here test that we have created the SLA test for the server 8.8.8.8, packet loss percentage, you can see latency 10 millisecond and 11 milliseconds for WAN 1 and WAN 2 respectively, jitter. So these are the 3 parameters that gets calculated when we send the probe to 8.8.8.8. And the rest of the parameter is failure threshold and recovery threshold that I have explained. Now let's try to configure the SD-WAN rule so that we can decide the traffic that should come onto the SD-WAN. So let's name it as allow traffic. And let's try to use source address as, let's try to create a specific one. Or let's try to use all for time being. User group, I don't need any. Destination address, you can type as all for testing. In your case, you can select the specific one. So here you have the option of selecting the outgoing interfaces where you can define what sort of control you need on your SD-WAN members. Either you can define manually, or you can go with best effort, low cost, or maximize bandwidth, where you can use both the links. Let's try to go with the best quality. The member with the best measured performance is selected, which I guess in our case is going to be WAN 1 because of the better latency and jitter value. Interface preference, you can select WAN 1 first, WAN 2 second. Zone preference, SD-WAN zone, since this is the zone that we have created in our firewall. Measured SLA, you can select the one that we have created, SLA test, and criteria is going to be latency, or you can select as packet loss, so that the decision is made on the basis of the packet loss value that we have seen in the SLA measurement. Click OK. So now we have the rule to allow the traffic. Status is enabled. Performance SLA, again, you can see, you can click on this. So as I said, the decision is made on the basis of packet loss, which is 0% for both the link, WAN 1 and WAN 2. You can change accordingly. And then next comes the routing part, where you have to create a static route pointing to the SD-WAN member. So let's try to select the interface as SD-WAN zone, where we have two of the interfaces defined. One is the static, other one is the dynamic interface, and WAN 2. So the SD-WAN will take care of which interface should be used by the firewall for the outgoing traffic based on the configuration that we have done. In our case, it is going to be the packet loss criteria. If the packet loss is beyond 10%, then that particular interface will be disabled by the SD-WAN configuration. Click OK. So now we have the policy as well. And there's one more thing that is left, which is the policy to allow the normal traffic on firewall. Create the normal firewall policy. We'll name it as allow. Incoming interface is going to be LAN. Outgoing interface is going to be our SD-WAN zone. So make sure you select SD-WAN zone. Source is going to be all. Destination is again going to be all. Service, any, all. And we do need NAT, because that's how we'll get the reply from the outside world to our system. Scrolling down, log all traffic, yeah, click OK. So now we are good to go. Let's try to check if we are able to see any data on the firewall. So we already have the data. Let's try to see if we can initiate some traffic and see. As you can see, we are able to ping 8.8.8.8. And if we go to SD-WAN, and you can see here based on sessions, bandwidth, volume, and if you click on sessions, you will see that port 1 is used. WAN 2 have one session, might be the probe session, the probe that firewall sends to the 8.8.8.8 server that we have configured. But then altogether we have 2 sessions, I guess. Okay, active session is 7 on WAN 1, and on WAN 2 it is 1. You can see the volume as well, pretty much self-explanatory. So now let's try to bring down one of the link to check if everything is working fine. I'll quickly bring down one of the link. I'll disconnect the cable. I'll pause the video for some time until I disconnect the link. So I have disconnected the WAN 2 link. So if we check it again, we should see some activity here. We might see the packet loss increasing. So you can see here, WAN 2 is down. It is beyond the threshold that we have configured. Threshold is 10%, which is for sure exceeded, and hence the WAN 2 interface is down. And if we go to SD-WAN, now you can see here, all the information. WAN 2 link might have some data from the previous session, so automatically the traffic will be redirected to WAN 1. And if WAN 1 goes down, the traffic will fall over to WAN 2. And this is how it works with the SD-WAN, where you have any of the members dynamically configured, as in when the interfaces gets the IP from the DHCP server. Before ending the video, let me try to show you the session information as well. So you can see here most of the sessions information here, 10.10.10.1, which is the client machine. And one more thing, what we can do is we can try to access Wikipedia to initiate some more session. So now you can see the session here, 10.10.10.1 going towards this public IP, and the return is for the netted IP, which is WAN 1. These are all a WAN 1. If you check, this is for the probe that I was talking about, the session that we see, the probe session failing. So now let's try to bring up the WAN 2 link, and let's try to bring down the WAN 1 link. We'll try to bring down WAN 1, and we'll bring up WAN 2 to check if everything is working fine as expected. I'll pause the video for some time until I unplug the cable. So now we have So I guess I have plugged the cable for WAN 2. Let's try to check the status in WAN performance SLA. Okay, seems like it is recovering. Still recovering. Let it recover so that we can bring down WAN 1 and put the load on WAN 2. And in our case, the best effort is selected, where the member with the best SLA will be chosen. Okay, couple of more probes, that's it. Yeah, it is well below the threshold, 9%. So now the link is healthy. Let's try to, we can do one thing. We can try to Let's try to bring down WAN 1. Okay, since I'm connected to Fortigate Firewall on WAN 1, let me try to disable this and let me try to get the access from the LAN interface. Let's try to disable this particular interface so that we can check if the traffic is falling back to WAN 2. Now let's go back to our system. This is the client machine. And let us try to check the status of our performance SLA. So this is the one. As you can see, WAN 1 is down, WAN 2 is active and falling under the threshold that we have specified for packet loss. Latency is not the criteria, so now we have the active member as WAN 2, and you can see the traffic falling onto WAN 2 link. Let us try to check the we still have the connectivity. Let us try to check the session information to confirm the same. And you can see here 10.10.10.1 falling back to the WAN 2 link, which is 14.140.40.108. all these sessions are now falling back to WAN 2, which proves that our configuration is working fine. That's all in this video. If you have any question, do leave them in the comment section. I'll try to answer them as soon as possible. And at last, please do not forget to subscribe to the channel and hit the like button. See you in the next video. Bye-bye.